Okay, last part of it. What style do you have left here? Okay, what style's left on the bottom? GCF. So I'm going to pull out an X, leaving me with X and subtract 5. Okay, so that's us recognizing all of our factorings. Now cancel what you can. So I have an X minus 5 on a top bottom. I have an X plus 5 on a top bottom. I have an X minus 1 on a top bottom. So how do you write the final answer in this case? 1 over X. Okay, you have to be careful with that placeholder. You can't just write X. It's different. It's on the bottom. Okay, dividing. So this first one, we have a complex. Okay, this time I'm actually going to put something into the last and last. What has to go last? 1 and 1. So now, what do I want in the front? What do I want in first? Do I want a 1x, 4x? Or do you think I'm going to want a 2x, 2x? 2x, 2x, because I'm creating 2x and a 2x on the outs and ins. So do you see how all those make my FOIL to make my trinomial? Okay, next, recognize style, simple. So 4 and the 3 can get you the 12. Okay, what do you want to do with that divide? What's a good thing in math to do with dividing fractions? Multiply, and then we'll be flipping. Okay, so 2x plus 1, putting on the bottom, there's nothing I can do with it. And what style is the 3 subtract x? It is one of those styles. It's a negative out because it has a negative variable in it. So negative 1 turns my x positive and my 3 negative. Okay, once your factoring is all done, you just look for cancels. So a 2x plus 1, top bottom. An x minus 3, and that's it. Okay, on this one you could have changed the top to that as well. I'm okay if you didn't. Okay, last one of that. This is a type where you just say, what can I cancel? So is there a number I can divide out of everything? I can divide by 4. So I'm going to cross that out and put a 4. Cross that out and put a negative 1. What else can I take out of top and bottom both? I could take a y out. So if I do, that's gone. And that's y to the 6. Okay, I can also take an x out. So that's gone. And that's an x to the 5th then. Okay, so there's your final answer. I just put the negative there. It doesn't really matter where your negative goes, but if you were to ever write what is 4 divided by -1, you would just write it as the number -4. Does that kind of make sense if I say it like that? Okay. Adding, subtracting. So, big idea, common denominator. Before I do that, I'm going to factor everything out that I can. So factor, factor, factor everything that you can now. See what you can come up with? Okay, how did it go? A 5 and a -3, a 6 and a -3 in your sets? Okay, so I want to go over here and say, what do I all need in my denominator? So I need an x plus 5 in there. I need an x minus 3 in there. And I need an x plus 6. As in, I could put my finger on those two, and then I could fit it in there. I could fit it in there. Okay, now what happened? So this first fraction had that and that, therefore it got multiplied by a x plus 6. Your second fraction had that and that. So what was the missing multiplier? X plus 5. Okay, distribute stuff. So 6x squared plus 36x. Distribute the second one. And did I catch any of you? That. Right? Remember, it's really hard to see it. You got to think -8 going through there, right? So that's a hard one. That's sometimes people forget. Okay, and then I can probably just simplify a little bit more by putting the x's together. What do you get there? 28 of them. Okay, next is the same idea. We're going to get a common denominator, but first I'm going to factor everything that I can. So see if you can start your factoring process on that. By the way, this first one is going to factor twice when you do it. You're going to have to factor and factor again. See what you can come up with.
Are you okay with that, Tracy, for today? Would be Gary's trainer? And you could do some tests together? Okay.
Okay, so here's some ideas you should have seen. GCFing an M out. And then you'd run into a simple trinomial out of that. Then on the other one, it was a difference of squares. Did that seem like it was okay? Now you're going to determine what do you all need in your denominator. So I need an m. I need an m minus 2. I need an m minus 1 to fit the first one in. And I'm also going to need a m plus 2. I need all of those in there. Okay, so looking at the first fraction, it had. It was missing an m plus 2. So multiply the top by m plus 2. Creating 4m plus 8. Okay. Second fraction, it had that and that. So it was missing an m and an m minus 1. Okay, now I'm going to think like this. If I have 3 things that are getting multiplied together, so I have 3 things, this, and this are all getting multiplied. I'm going to multiply 2 of them. And then when I'm done, I'll multiply it by the third thing. It doesn't really matter what order, but I like to do this first and then multiply by the number. So what does this make? M squared minus m. Then I'm going to multiply it by 7. So 7m squared minus 7m. Okay, and then you can just simplify the top if you have anything that you can put together. Okay. Complex. Okay, I'm going to do that. Okay, 2 over x plus 3, there's actually nothing to do. Okay, this bottom, I'm going to put that over 1 just so I know. Now when I put these together, I need a common denominator. So I'm turning the denominator into an x. Therefore, I'm going to have to multiply this by x. So this becomes x. Nothing changed. Okay, so that's the first step. Then we're going to rewrite it, multiply, divide. So 2 over x plus 3 stays. And we're going to multiply and flip. Okay, then if I can cancel anything, that's what I would do. And I'm going to test you to see if I can trick you here. Why do you think I would trick somebody on this question? What would be the thing that could be tricky? Well, people would see the x plus 3 and the x plus 3 and think I could cancel them, but you can't. Why can't you cancel them? They're both on the bottom. The only way you can cancel if it's a top and a bottom cancel out. So nothing cancels. So there might be somewhere on your test where I kind of see if you're going to do that by accident. So remember, canceling is only a top-bottom cancel. You don't cancel sideways. Okay? Sometimes the concept would be some people think the x and the x should cancel there. Remember, you can't cancel adders. As in, thinking this, I can't cancel and say that that's 1/3, right? 5/8 is not the same as 1/3. So those don't cancel. Those don't cancel. Do you see a difference? Okay, solving equations. So solving two strategies. So you have to say which one are you picking. Your choices are cross multiply or common denominator draw. Okay, so which method do you think this one is? Cross multiply. Okay, so x times an x plus 11 is going to equal a 3x times a 2x minus 3. Okay, distribute that all out. Okay, what do you ever have to do when you see x squareds and x's? The moment you see x squareds and x's, you got to put 0 on one side. You got to move them all, put with 0 on one side. So I'm going to go this way. So 6x squared minus an x squared, right? I'm minusing that x squared away, is 5x squared. And I'm going to have to minus the 11 to make the 0, so this makes negative 20x. Okay, so instantly when you see x squareds and x's, 0, one side. Now you can look at it and say, what do I want to do with this? GCF. So I'm going to take a 5x out. X, subtract 4. So x is a 0 or x is a 4. Am I allowed to have 0? Am I allowed to have 4? What are the values you don't want to have? You don't ever want x to be 3/2, which is like 1.5 as a decimal, and you don't ever want x to be a negative 11. So we're good. These are allowed to happen. Okay, and the last one here, cross multiply or common denominator draw. Common denominator. So first I'll want to factor what I can. So out of here, do you see a GCF style? That's a GCF style. You can take an x out. X plus 1. So therefore, what do I need? I need an x. I need an x plus 1. So there's your common denominator. So now, what do I need to multiply everything by? So the first fraction will get multiplied by an x and an x plus 1. The second fraction is not going to get multiplied by anything. And the third fraction would get multiplied by an x. Okay, so here is this times this times this. So 3 things timesing. So times 2 of them, finish, times it by the other thing. So I'm going to go here. That times that makes x squared plus x. And then I'm going to times it by 2 after yet. So those are the 3 multipliers put together. So 2x squared plus 2x. We did nothing to this fraction, so I need to leave it. Minus 1 equals 3x. Okay, common denominator drop. So drop it. Okay, big grade 11 moment. What do you do with something like this? So your first instinct should be, I see x squareds and x's. I gotta get 0 on one side. So 2x squared minus x minus 1. Okay, once we have 0, now I can say, well, can it factor? Formula, what do I want to do? So let's try the factoring. 2x and 1x have to go there and there. It has to end with a 1 and a 1. So you don't have many options, right? That's the only way to make 2x squared. That's the only way to make 1. You need to make sure your positives and negatives are okay though. So your outs and ins need to get you a negative x though. So the outs, I have a negative 2x and a positive x, so that works. So your solution is negative a half or positive 1. Okay, are we allowed? What are the values I'm not allowed to have in the bottom? 0 and negative 1. I'm not allowed to have a 0 or a negative 1, so I'm okay. Okay, I was thinking we should do one of every word problem. If that's okay with you, from Monday? Okay, a solution of 10 liters is already mixed. It's got antifreeze in it and water in it. And it's 30% strong right now. How much antifreeze is in there right now? %30 of this liquid is antifreeze liquid. How much? 3 liters is the antifreeze. If you don't know how to do it mentally, then you can just say whatever it is times 0.3, right? That's how you do 30% of something. Okay, now I'm going to dump in more antifreeze. I don't know how much more, because I'm trying to make it stronger to 50. Okay. So remember, this was my strategy. The amount of chemical divided by the amount of fluid. So how much chemical did I start with? Some chemical? I started with 3 already. And then what did I do? I added more chemical, but I don't know how much more, but I added more. And the total fluid, well, when I started this thing, I had 10 of fluid, water, antifreeze, whatever. And then once I started pouring antifreeze in, that jug was also increasing in fluid. Okay, so fluid is just anything, right? The water, the chemical, everything together. And now I want it to be 50%. Okay, did you think of a method? Cross multiply, common denominator drop. Okay, why don't you see if you can just finish that off on your own? So the cross multiply, I'm guessing you're going to run into some isolation algebra stuff. Okay, so how's it going? Did you come up with 4 liters of antifreeze you're going to dump in? Sam, did you get that? You're giving me some eyes. Did you get this line, the 300? 100x is 500 plus 50x? So you had a 5 here? Because you need 50%. Did you do 5 over 100? Oh, okay, yeah, because so 50 would be 50 over 100. So yeah, so then just add zeros when you do that. Okay, your answers also should kind of make a reasonable sense, right, in your head. If you get a crazy number like 100, you probably are thinking that seems really weird for this amount of fluid, right? Okay, time and rate questions. We have a John and a Jacob. So I'll do that just to help organize my ideas. So remember this. Your rate is how long it takes you by yourself to do a whole job. That's what a rate is. A time is how long you work for. Let's say if you work with somebody else, that's how long you're working for in that moment. So, it takes John 45 minutes to push mow the yard. What is that? Time or a rate? It's a rate. So John's rate. If Jacob helps, then it would take them 25 minutes to do it. So that is a time. Because that's not a rate, because it's them doing it together, which means that's how long they ended up having to work. So if Jake were working alone, how long would it take him? So that's a rate. Okay, so setting it up, time over rate. So that's John. John did 25/45 of the job. And Jake did time over rate. And what happened when they worked together? They completed the whole job. So, cross multiply, common denominator drop. That's what you're thinking. So common denominator drop. So I need to have a 45 and a J in there. Is anybody predicting what Jake might be? Is he faster or slower than John? He's going to be slower than 45 minutes because if John was doing 25 over 45, he's doing over half of the job. So if you're doing over half of it yourself, you're faster. Okay, did you figure out your multipliers? You're going to multiply that one by a J and that one by a 45. Does anybody have this big number here? 1,000? 125. Okay, common denominator drop. So this kind of equation is an isolation because you're only dealing with one type of variable. So get the variables together. So do you see as I go, I understand when I'm isolating versus when I'm going into the factoring mode. This is an isolation mode. Is it 50 some minutes? So that's how long Jake takes by himself. Okay? Okay, so we did this pool question. So we were filling up a pool. So we were doing a time and rate on this one yet. Time and rate. We had 3 different hoses we were using. So if you're going to use just the hose number 1, it would take you 20 hours. So is that a time or is that a rate? A rate. If you're going to only use hose 2, it would take 15 hours. Also a rate. And if you're only using hose 3, it was 25. Also a rate. So if you could use all 3 of them together, how long would it take? So that's that is one variable, because when they're all together working, they're all going to finish at the same time, right, when the job's done. Okay, so the time over 20, time over rate, plus the time over rate, plus the time over rate, all three of them work to get the job done. Sam, you always seem to have my numbers. You already have my common denominator. Oh, what's the number? Do they all divide by 100? No, I don't think 15 does it? What about, what do you think it's going to be? 500? No, 15 doesn't divide. Anybody have anything? 400? Does 400? What'd you have? 300? 300! 300? Yes, 300 will work. They all will work with 300. Okay, what do I get? So, 20 would have to get times by 15. Therefore, 15 would have to get times by a 20. How many 25s can you fit? 12. I feel like I should not use a t as a variable. T and a plus sign together. Okay, common denominator drop. It's gone. What do we get there? 15, 20, 12, 47. So it took 6.38 hours to fill the pool up when they're all going at the same time, assuming your water pressure is the exact same. At my house, it would not be. Okay, about travels 18 miles upstream, the same time it's going 20 downstream, and you have a current of the water. So I'm going to start like this. The time to go upstream is the same time to go downstream. Okay, in that maneuvering of the velocity formula, what is the time? What do you want to do here? What's time is equal to distance over velocity? Okay, so that's what I'm going to do, distance over velocity. Now I have to fill in stuff. So what is the distance as I went up the stream? 18. So the velocity, you have your boat speed, which is unknown. You're going upstream, so what do you want to do with the 2 in the water? You're going up the stream. Would you add it to the velocity or subtract it? Subtract it. It's making you slower. It's coming at you. As you go down the stream, you went a distance of 20, and the velocity was your boat traveling. And now you're going to add, right? Because you're going down the stream, so the current is adding to your boat speed. Okay, what do you think? Would you know where to go from there? Cross multiply strategy? Is that what you were thinking? All right, everybody's working on their own here. Let's see if we can all match.